Okay, let's continue working on number 6. We were almost done. So we translated the equation, we removed parentheses, we combined like terms, and then we realized it was a quadratic. And anytime it's a second degree equation, we learned on page 1 of these notes that it must be set equal to 0 before you decide on the factoring pattern. So here's a thing that you guys should write down, because this would help so many students if they would just write it down and remember it. When you see two terms, there's only 3 things it can be: GCF, squares, or cubes. That's it. That's the only factoring patterns we know for 2 terms. And you do it in that order. GCF first. Do you see a GCF? Yes. So if there wasn't a GCF, then you'd look for squares. And this is not a square, so that's definitely not a square. And if it's not a square, then you look for cubes. So that's the only thing 2 terms could be. So in this one, we have a GCF of x, and we did one just like this about 2 pages ago when we were solving our quadratics. When we take an x out of each term, we have x minus 7. So 2 minus 1, x to the first, x's cancel, equals 0. Then we learned on page 1, if a times b equals 0, either a is 0 or b is 0. So x is 0 or x is 7. And like I said on the last problem, we always get 2 answers, but with word problems, not with regular problems, both answers work. But with word problems, usually only one of the answers works. So let's see what it says. 2 consecutive positive integers. 0 is not positive. So since this one is, I go up here and I say, okay, x is 7, then put my 7 right there. 7 plus 1, the second consecutive integer is 8. And they're both positive. They're both right in a row. That was a guess up there. Totally random, but it was a good guess after all, huh? So there we have it. 7 and 8 are the 2 integers, and you could test them. You could read the problem and test them and make sure that they worked. Their product's 56. Their sum is 15 times 4 is 60. Is that 4 less? Is 56 4 less than 60? Yes, it is. So that tells you it works. Okay, so I did not put one like that on a test, but consecutive integers are very common in Math 150. So, and they were common in 091, the class before this too. So that way you will have seen them even if you didn't take 09. So this is the last part of our section. We're going to practice finding X and Y-Intercepts again. If you're in Math 126, you already had a unit on X and Y-Intercepts. For the X-Intercept, you always make Y 0. For the Y-Intercept, you always make X 0, which we're going to talk about. But let's just go over some of the quadratic. And this we had earlier in the prerequisites, chapter 2. So this is what a quadratic function looks like. Its highest power is 2. F of x equals ax squared plus bx plus c. So when we have y equals, it's called wow, I can't talk right. When we have y equals ax squared plus bx plus c, we call it a quadratic equation. But when we replace y with f of x, then we call it a quadratic function. The reason a can't be 0 is then it wouldn't be a quadratic, because 0x squared means it's not there, so it'd be y equals mx plus b. It would be a line. So that's why a can't be 0. So we learned in our prerequisite chapters that quadratics graph as parabolas. They either cup up when a is positive, or they cup down when our leading number is negative. So negative means less than 0, positive means greater than 0. So If this was a 5, it cups up. If this was a -3, then it cups down. And it's the leading coefficient, the number in front of our x squared, that determines whether it cups up or cups down. So that's important. So when a is greater than 0, it opens up. When a is less than 0, it opens down. And then let's highlight this. This is from our prerequisites chapter, or from your 091 class. When we're finding the x-intercepts, we make y 0. Why? Because every single point on the x-axis has y0, 1, 0, 2, 0, 3, 0, 4, 0. So we're not making that up. That's just a fact. Every single point on the x-axis has y0. To find the y-intercept, we make x0. And we're going to have to find both many, 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 many times in this class. So you always set the other variable equal to 0 when you're finding the intercepts. So let's look at this example here. Find the x and y-intercepts of this. And remember, f of x is really just y. Don't forget that. So to find the x-intercepts, we make y0. So we have 0 equals -4x squared plus 4. Well, isn't that just a quadratic set equal to 0? Yeah. So we go through our factoring patterns. 2 terms. What did I tell you above? When it's 2 terms, it's either GCF, squares, or cubes in that order. So first I go, oh, there is a GCF. And we learned that when the leading coefficient's negative, we're supposed to take a negative out of the GCF. And that we did. So I took out -4 as my GCF. So what's left after I take out -4? Positive 1x squared and -1. Oh, look at that. Now it's a difference of squares. So we can continue going. X plus 1, x minus 1. Remember, we take the square roots, and this tells us the signs will be different. So using the zero factor property, if a times b times c equals 0, then either a is 0, or b is 0, or c is 0. So -4 can never equal 0, so that's out. So to get your two solutions, or your two x-intercepts in this case, you solve those, and you get x equals -1, or x equals 1. But remember, on x-intercepts, y is 0, and we learned in the prerequisite chapter that that means intercepts are points, so you have to write it as a point. -1, and then up here we said y is 0. That's the first place the graph crosses the x-axis, and +1, 0 is the second place. And this one, the leading coefficient's negative, so I know this parabola is going to look something like this. When y is 0, or when x is 0, I get 4. So we haven't found the y-intercept yet. But just from what we have, I know this. So I know it cups down because a is negative. I know it crosses the x-axis at -1, 0 and +1, 0, and then we're going to find this point now. So much just from this little teeny bit of algebra, you can draw the parabola. So to find the y-intercept, we make x0. So go into your original problem. Y equals -4 times 0 squared plus 4. 0 plus 4 is 4. So the y-intercept is 0, 4, which I already drew up there because I did it in my head. So look at that. Find the x-intercepts, you see where it crosses the x-axis. Find the y-intercepts, you see where the parabola crosses the y-axis, and we know it cups down because the leading coefficient's negative. So that's where all of this is leading us so that we can draw accurately the parabolas. Okay. So the big thing from this page is remembering A positive cups up, A negative cups down. To find the x-intercepts, make y 0. To find the y-intercepts, make x 0. Okay, let's move on to the last page of our notes. So this one's asking us to find the x and y-intercepts. So to find the x-intercept, remember we make y 0, and be sure and write it down because you want to make sure your final answer has a point. So to find my x-intercept, make y 0. So remember, this is my y. So I take 0 equals negative x squared minus 2x plus 3. And because this leading coefficient's negative, I know this parabola cups upside down, right? Okay, so we learned you can never have a negative out in front. So the very first thing you want to do when you see a negative is bring out that -1. Nothing else is common. So that means my GCF is just -1. So I get x squared positive 2x minus 3. So I'm going to flip it around here. So -1 x squared plus 2x minus 3 equals 0. So remember, I'm finding the x-intercepts. Well, that's why this is in this chapter. When I have a quadratic set equal to 0, that tells me to factor to find the x-intercepts. We learned that when the leading coefficient is 1, we do not have to do AC method. We can go straight to the answer. So we do x and x. This says the signs are different. So I make 1 plus and 1 minus because the only way to get a negative is by multiplying a positive times a negative. So I'm looking for factors of 3 that when I subtract them give me 2. Yep, 3 minus 1 is 2. This says the signs are different, but this says make sure the larger number gets the plus sign. So 3 is going to be plus, 1 is going to be minus. So put the 1 with the minus, the 3 with the plus. And then our last step of finding the x-intercepts is if a times b equals 0, then one of these three things must be 0. Well, that's never true, so we can cross it out. X plus 3 equals 0, or x minus 1 equals 0. So we get x equals -3, or x equals positive 1. So my x-intercepts, let's put them up here. So my x-intercepts of this graph are going to be -3, y is 0, and you'll see this is a huge concept coming up in chapter 7. All we do is graph parabolas, and this is the first thing we have to find before we graph them. And my second x-intercept is 1, 0. So now I know the two places that graph crosses the x-axis. And then the second question they want is y-intercept. It's always the easier of the two. That's where you make x 0. So y equals -0 squared minus 2 times 0 plus 3. So you go in the equation, and everywhere you see an x, you plug in 0. So -0 squared, which is 0, -2 times 0, which is 0. So 0 plus 0 plus 3, so y is 3. So that makes my y-intercept, and they're always points, remember, 0, 3. So now you should, on the next video, we'll go over the next one. So in between videos, you should work this one out all by yourself. because I know it's on this test. I know it's on the Chapter 7 test. I know it's on the final. So go ahead and work that